Hi, my name is Dale Lane and I'm a developer for IBM. And I'm going to be talking about a project called Conversational Internet. Now, the idea behind the project is getting information from a computer by asking questions. Now, this isn't a new idea, it's been around for decades. Even back in the 60s, Captain Kirk's computer on Star Trek could do this. Kirk could get the information he needed by asking the computer questions, like, what will happen if we do this? And 50 years later, technology is still moving towards this vision. We can now make software able to handle requests to look up answers.
How many people live in Cape Cod?
The population of Cape Cod is 215,888.
Awesome.
Not only that, we can build software able to answer complex questions, software that can draw on a knowledge that it's learned for itself by reading and understanding the text in books and magazines, newspapers and encyclopedias. I'm talking about IBM Watson, the computer system that we entered into a TV game show in the United States last year as a way of demonstrating the progress that we had made.
Don't worry about it, all the way down at 2,000, Alex.
It's just acne. You don't have this skin infection, also known as Hansen's disease. Watson.
What is leprosy?
You are right.
Etude brute for 1600.
Music fans wax rhapsodic about this Hungarian's transcendental etudes. Watson.
Who is Franz Liszt?
You are right.
So these are things that we know how to do. What else could we do? How else could we move towards this vision of the computer as our assistant? RLSB encouraged us to look in particular at screen readers, to look at the experience of users of screen readers, and to see if there was anything that we could do differently.
Link accessibility help list and navigation region start heading level 2 bbc.co.uk navigation list of 8 items link news link sport link weather link iPlayer link TV link radio link more link graphic Olympics link London 2012 list and search region start search term : edit search unlabeled 9 button search region and navigation.
Think about the division of work between the user and the computer when you're using a screen reader. The computer reads out the words and elements on the page in the order that they appear. The user, besides having to decide what it is they actually want to do, has to understand what the page means. They have to combine the series of elements they hear read out into some sort of mental model of the page, remembering roughly what went where and what their options are. They also need to be able to translate the goal that they want to achieve into the series of physical actions necessary to accomplish it, whether that's pressing the tab or the arrow keys the right number of times. Well, can't we shift this balance a bit? Couldn't we get the technology to do a little bit more? Couldn't we require the user to have to do a little bit less? Because wouldn't it be better if the technology understood more of the page it was reading? Wouldn't it be better if the technology understood more about what the user wants to do and what steps would be necessary to achieve that? Let me explain what I mean. Firstly, by technology that understands the page. When a screen reader understands some of the page that it's reading, it doesn't need to read it all out. It can just describe what's important.
This looks like a category page for a news site. There are a number of links to articles. There are menus and a search box.
Now, if I want to know what the menu options are, I can ask. If I want to hear the list of articles, I can ask. Let me know what's available, let me decide what to do next. Don't just read out everything. And what do I mean by technology understanding the user? Well, when a screen reader understands what it is that I want to do, it can do it for me. So for example, if I want to go to the politics section, I can just say that, go to politics. I didn't need to know where the menu was. I didn't need to know how many tab presses it would take to go through the menu to get to the politics item. I just describe what it is that I want and let the software figure out what is necessary to achieve that. It's not just about clicking either. It can be any interaction with the page. Say that I want to search the site for something. I don't need to know where the search box is. I don't need to know how to get to the search box. I just say, search for David Cameron. The screen reader finds the search box, enters my query into it, and submits it. I'm taken straight to the results, which are then described to me.
There are 18 search results on the page. One is in a section labeled 24 November 2012. 11 are in a section labeled 23 November 2012.
This is the idea we worked on with RLSB. Creating software able to interpret web pages and offer a natural conversational interface to web browsing. Now, I don't have time this afternoon to explain in detail how it works, but I wanted to highlight a couple of the key approaches. Technology is getting better at interpreting unstructured English text. We can understand what some of the text on a web page probably means. For instance, if the web page contains an instruction to do something, like enter your postcode here, we can spot that call to action and highlight it to the user. We're also getting better at training computers to perform tasks. Because we don't want to have to manually craft hard-coded rules that would be specific to some website or page, rules that would stop working if the web designer changed the layout of their page. Instead, we want to train the software to be able to learn for itself from experience how to interpret the structure of a web page. To do this, we take a large number of web pages from sites across the web and we manually annotate them. We tell the software what part of the page contains the menu, the categories for the site. Now you do that for enough pages, and the software is able to build up a machine learning model from that experience. The idea is that if you then give it a new page, it's able to apply that model, and with some reasonable level of confidence, make an estimate of what part of that new page probably contains the menu. Now internally, the sorts of features it will be using to do this will be many of the same sorts of visual cues that I would use as a user. This is a series of links. Are the text and the links quite short? Are they arranged vertically or horizontally? Are they near the top of the page? And so on. Because the point is, over time, as a sighted user, I come to recognize patterns in the structure and layout of the different websites that I visit. Now, our aim is to create machine learning models that perform a rudimentary analog of this learned behavior. And by doing this for search boxes and headings and menus and comment boxes and more, we've been able to train the software to recognize what many parts of a web page must mean. University students came to our R&D lab near Winchester over the summer, and they built the first version of the prototype that I've been showing. Now, it's a work in progress, and it's more effective at some sites than others, but it's an exciting start, and it shows the potential of applying these sorts of technologies. And although originally conceived as an assistive technology, the future of this approach could have value for all, in the same way that technologies like Siri today are used not just by visually impaired users. The future of a conversational internet could be useful and convenient to anyone who wants information from the web.